Wild, is it that wild? I don't know. Let's see what people say. We'll see if we get a couple of strategies here. I could think of 3. I thought of 3 strategies. Okay? One that's sort of within the realm of what you've seen. One that's super clever and easily within the realm of what you've seen. And then a third one that's way out there. Okay. Anybody have an idea, even if you didn't do it, on a plan of attack here? Ellie, what do you like? I think that's strategy number 1, and probably the best strategy for us, is if we find the midpoint. I know where she's going with this. If you're not sure where she's going with it, she says, let's find this midpoint. And what we mean by find it is like, let's get it algebraically. Let's know, like it sort of looks like we can already see what it is, but that's not what we're going to be about. Because if the numbers are big, or there's crazy decimals, eyeballing it is not going to be very accurate. So we're going to find that midpoint of QR. Okay? So midpoint QR equals, write down the formula, x1 plus x2 over 2, y1 plus y2 over 2. And Ellie, did you actually do that, or did you make the plan? She actually did it. Okay, so I'll do it, and then we'll check our work, okay? So I get 5 plus 8 over 2. And I get 4 plus 7 over 2. She's going to check my work for me in just a second. Or we're going to compare, are we? I get 13 over 2 and 11 over 2. And just to get sidetracked a little bit, what is it about this situation that makes me go, I can just do decimals? I'm not even worried about it even one little bit. Because I'm trying to build some wisdom here over the next couple of years about decimals. Why are these decimals like, yeah, it's no problem? Did you do decimals?
Yeah, but I think I did wrong.
Oh, did you make a mistake? Did I make a mistake? Let's compare in just a second. This is what math's about sometimes. I know some of you check collaboration on your improvement thing. And this is what it's about. It's about not just working on it yourself, it's checking with somebody else, texting someone else, Instagram, something to go, how did I do here? Because it's easy to make little mistakes. I get 6.5 and 5.5. But back to my question, what is it about these decimals that makes me go, decimals are fine? No one could argue that decimals aren't fine for this question. They're 0.5s, yeah. The truth of the matter is, if it was only halves in this world, if that was the only fraction in this world, we just all use decimals. It would be nicer. But it's not going to just be halves. And so that's why we practice our better fractions. But for here, we'll use decimals because it's a crazy question. So let me label it on there. Now, Ellie, do we agree? You say maybe you made a little oops? Yeah?
Yeah, I found a mistake.
Yeah, so, okay, you got this. All right. The graph sort of verifies that. It sort of makes me feel good that that would be the right answer. Now, why does that matter? Because that's not the base. It's not the height. It's not any of those things. Where's she going with this? What did you do next? Oh, yeah. So we'll label that M, because there's only going to be one midpoint in this question. So even though I called it MQR over there, there's only one M in the question, so maybe I don't have to get too specific. And yes, that's a big deal, labeling these things as we go along. Anyways, she connected those up. Why? How? Why? Let me just finish labeling this over here. And I wrote too big and left myself not much space here, but that's okay. What did you do next? Find the length of that line, okay? Now, all this only works because this was isosceles. If this wasn't isosceles, really scary, okay? So anyways, so she found the length of that thing, the length of PQ, and she's using this formula. So, x2 minus x1 is 6.5 minus 2, which is 4.5. Somebody asked me yesterday if they could just do that. Just write the delta x in there. Because they saw it easier with Pythagorean theorem. They just went, oh, well, that's 4.5 there. And I said, yeah, but be careful. It's easy to believe, oh, I'm so good at this, I don't need to write down the one extra step. I think on tests you write down the extra step, just to make sure the little mistakes don't happen, right? So what? That was 4.5. The delta y is 5.5 minus 1. Oh, which is 4.5 as well. I'm trying to show that step skip that I'm not a big fan of, but I'm trying to address what somebody said about it. And so here I get, ooh, maybe I need my calculator for that. Uh, 6.5. 5. Wait, something's wrong. There's no way those are both the same. See, that's why. That's why we don't like steps like that. Whoever you are, whoever I said, yeah, go ahead. I take it back. Be careful here. 6.5 minus, this point here is 2 comma 1. 6.5 minus 2. And this is 5.5 minus 1. Oh, no, I was right. See, but I wasn't feeling confident about it. 4.5 squared plus 4.5 squared. Oh, that's going to be a mess, isn't it? Equals square root 4.5 squared plus 4.5 squared. I get 40.5. And when I square root that, I get 6.36. All right. Now we're getting close here because now she's found the height of the triangle if I turn this way. She's going to use this as her base and this as her height. How did you get the base then? Now she needs the length of QR. Ooh, length of QR equals square root of, okay, so I'm going to label these points again. 5, 7. And this one was 8, 4. And so I go 3 squared plus negative 3 squared equals square root 18 equals, I get 4.24. Now I'm almost home. Yes? Now I can go back up to my original formula, base times height over 2, and go, okay, base was 6.36. Height was 4.24. And then divide that all by 2. 6.36 times 4.24, divide that all by 2, and I get 13.48. I need to tell you, the answer is 13.5. What could I have done differently to have kept the 13.5 intact? Yeah, use the roots here. Call this square root of, let's see, that'd be 9 halves. And 9 halves is 81 quarters. No, 81 halves, sorry. Keep that like that. And keep this as root 18 and multiply those together. And you'll get the exact answer of 13.5. Do we hold you that in grade 10? No, no, no. No, that's a complete preview of things that are coming later when we want to get exact answers. Okay? All right. Did other people see that method? Who else saw that method? Not bad when it's an isosceles. Is that a test question? Wow. I think if I was going to put that on a test, I'd guide you through it. I'd say something like, find the midpoint of M, or of QR. So you'd find the midpoint of QR and go, okay, that's pretty good. Draw it on your diagram. And you draw it on your diagram and go, oh, connect that point P to M. What do you see? Can you now find the area of the triangle? Something like that. I wouldn't just leave you out in the cold like that at this point in the course. Now, did anyone see a different way? Josh.
I didn't use any of that. What I did was that, I guess, instead, like I found the midpoint from there. What I actually did was that I took the measurement, it was like 4.2, and divided it by 2, so I got 2.1.
Yes?
And I cut the triangle in half, and then I just used the Pythagorean theorem.
Yeah, he went here and he said, okay, I'll use the Pythagorean theorem. What did you do? Find this length here. and you had this length there, and since you knew that was right angled, you did Pythagorean theorem to find that height. And then you got the same height we did you?
Yep.
Yeah.
6.36.
6.36. This is why we collaborate and we talk about answers. Not because we're going to steal Josh's method. Maybe we're just going to steal his method. I don't know. But maybe we go, oh, you got the same as me. Oh, I feel great about my 13.48, well, 13.5 answer. Did anyone see anything else? All right. I think you have to see stuff like this once. I'm not sure many people would have came up with this the first time you saw it. I'm going to switch to highlighter. I'm going to switch to color yellow. I'm going to make sure my pen's small enough. Watch this. This could change the way you look at some geometry problems. Another way to do this is just to make a rectangle around the whole thing. Because that rectangle, I can find the area fairly easily just by counting squares, or length times width. And then every single triangle is nice and easy after that. Yes? Do you see all those three outside triangles? So I could find the area of all those triangles, all that yellow stuff, and subtract it from the area of the rectangle. Good fun and mind-blowing. You're like, oh. You see, that's the kind of thing in math when you see it, you're like annoyed. You're like, what? Come on. But they're good to see, and it will give the same answer. Okay? I am not suggesting every single geometry problem can be solved by drawing a big rectangle around it. That is not true at all. There are definitely geometry problems that you'd have to do the steps we did. But this will work in this situation. And it really relates to the Pythagorean theorem and the roots of where that comes from. Okay? Questions on that? There is a theorem out there called Heron's theorem, way beyond the scope of this course. But let me show it to you so you can see it, that you can take. Oh, let's see if I'm right. My memory told me it was called Heron's theorem. Heron's formula, good, for area of a triangle. And let's see what Heron does if it comes up in any short period of time. Heron's formula. And Heron's formula, if Wikipedia ever comes up, is a formula for finding the area of a triangle using only the sides. The development is absolutely crazy, but if you have each of the side lengths and the semi-perimeter, whatever that is, which is half the distance around, there's a formula out there for it. We don't even talk about it in grade 9, so it's like if somebody asked you before today, they might say, can you find the area of a triangle just from the three sides? You'd probably say, no, you can't. Heron says differently. Let's see, for calculating square root, I don't see the year on this. I believe it's a very ancient theorem, though. I believe it's old. Let's just scroll down and see if we can learn a little bit more about it. Not part of this course, but I did want to mention it. I didn't want you to leave. Look at, here's another way of expressing it. Look at that thing. History, 60 AD. So upwards of 2,000 years old. Somebody was playing around with this, okay? And there's some crazy proofs. None of these proofs do we have what we need yet to do the proof, although this year, the starting of that proof right there, see that formula right there? I will do that formula this year. We will talk about cosine. And when it happens, you won't think it's particularly difficult. Many people think grade 10 trig is very, very straightforward. It's the easiest chapter. They like trig. So I know this formula looks wild right now, but when I teach it later, you'll be like, oh, okay, yeah, no problem. Yeah, okay. All coming soon to a math class near you.